Hi, Junior Superheroes. Welcome back to Gotham. This is part two of my three-part sneak preview to where we're going this term. Um, so by now you're familiar with Batman, and this is the road that you're setting out on. You're well on your way to becoming Batman, leaving your mere mortal status behind, and getting ready to leave the Batcave.
To the Batmobile. Let's go. Atomic batteries to power. Turbines to speed. Here, ready to move up.
All right, so here we go. There's no turning back now. Okay, so to give you this sneak preview to where we're going to be in about 10 weeks or so, I want to walk through an example much like we're going to be using at that time in the semester. So as I've told you before, I like to give you this preview so that you know where we're going. It's no fun to go on a hike to get in the woods if you really have no clue where you're going. It's nice to have a visualization of where you're headed. So this is what this is for, to see what we're going to be doing. So it's not, and hopefully so you can see that it's not quite so scary. So the example that I want to use is an experimental example. So let's imagine that we were going to do this quite simple design study. Our primary interest, pretend, is we want to know if meditation can help people who are suffering chronic pain. So I went to Google to see what meditation might look like, and these are some of the first pictures that I found. Apparently you must sit like this with your fingers touching, and apparently this is how you must meditate. And if you get really good at it, you might be able to float. Okay, so this sounds like a simple question. No, does meditation help people in pain? Now, in Research Methods course, you're going to learn much more about the method that you would use the best method to select to try to answer questions like this. And so I don't want to give too much away of what you're going to do in that course, but there's a lot to consider and a lot to think about. This is not quite as simple as it might sound. So there's many factors that need to be considered when you're designing a study, even one like this with a pretty simple sounding sort of question. So for example, there's the question of operational definitions. Meditation and pain, the two primary variables in this hypothetical study, need to be defined clearly. What do we mean by meditation? What do we mean by pain? So that's what an operational definition entails. It defines how you're operating with the term. Now, an operational definition differs from an everyday dictionary kind of definition in that it doesn't have to be the most precise, best definition. It needs to be one that's clear enough that says how you're using the variable. So if you're talking about meditation, you need to be clear. What type of meditation? Where is it being done? How often? And so on. Okay, so that needs to be defined, and likewise, pain needs to be defined clearly. So, how are you going to measure pain at the end of a study like this? Okay, so that's not always a simple task, coming up with operational definitions. That's where surfing through the prior research and literature on a topic certainly comes in handy, and find out, what others have done, how they have defined and operated with the terms, okay? So let's flash forward and assume that we have a clear enough definition of meditation. We know what it's going, how the individuals are going to use it. We've operationally defined who our pain sufferers are going to be. That's another, the population needs to be clearly articulated. So what do we mean by chronic? Well, chronic versus acute pain. So all of these things, again, need to be very clearly defined. So again, let's flash forward and assume that we have some well-defined population of pain sufferers who have had it for a long time, not just because they've recently broken a bone or had some kind of, recent, fairly temporary injury, but more of a more chronic nature. And we've defined what we mean by meditation, what type of meditation, how long, how many times it's conducted, and so on. Okay. So other issues and other variables would need to be controlled. This takes us back to the snapshot of a simple case experiment that we went through in another presentation. So we have to talk about all the possible or known confounds that could come in if we were to allow them. So for a simple one, for example, if you're going to start out with two conditions, a group that's going to meditate and a group that's not going to meditate, one very simple confound would be if one group was already in more pain or a different type of pain than the other group. So if at the end of doing the meditation or the lack of meditation, you saw a difference, well, you wouldn't know if it was due to the meditation or the lack thereof, or if it was just because the two groups already differed to start out with. Okay, so that's one very obvious sort of confound that would need to be controlled, and that's fairly easy to control. Give them assess their pain ahead of time. Okay, in most kinds of studies like this is bordering on medical research, right? If we're going to talk about a treatment for pain. Particularly when you're doing those kinds of studies, so-called placebo effects are a possible issue and source of confounds. So what is the effect of knowing that you're in a meditation group or knowing that you're not in a meditation group in a study on pain? So those are another series of confounds that need to be addressed. How can you do this in a so-called double-blind fashion where the participants aren't clear which condition they're in, and the people taking the assessments of pain and interacting with these people, it's important that they don't know whether they're meditators or not. Now, that might sound like a simple, unrealistic thing to do. How can you get people to do a control version of meditation? It looks and feels and resembles meditation in every single way possible, except that it does not include the primary ingredient, whatever it is, of meditation. Well, it can be done. For example, let's say that the population is people who are residing in some sort of hospice for their pain or cancer or whatever larger issues they might have. Now, these people would have a daily schedule and all kinds of things that the staff and so on, the doctors and nurses and whatnot, would be implementing and administering with them. And so perhaps meditation could be worked into the routine of a day without it being really obvious that, hey, we're testing this meditation to see if it reduces chronic pain. It could just be kind of slipped in on their daily routine as something just to sort of help them, and and not such an obvious we're studying this kind of way. Because right as soon as you identify that this is a variable that we're studying, then you have possible biases that could come into play. And likewise, you could have the control condition, another group of equal pain sufferers that just don't meditate. They're not aware that others are, and they're not aware that they're not either. So it can be done. So you could do this in a double-blind sort of way. All right. Well, in methods, you learn much more about the design, selecting and articulating your variables, identifying confounds, and figuring out which individual difference kind of variables, which extraneous variables you would like to include and which ones you wish to control and exclude. Okay, so let's pretend that we've got that all taken care of. We've figured out what we mean by meditation. We've figured out what we mean by pain. We've got it, the optimal design. Okay, so let's assume that we've got some kind of counterbalanced double-blind between groups experimental design. How's that for a mouthful? I've already explained the double-blind part of it. Counterbalanced, I kind of touched on. We want to make sure that the two groups are balanced in their pain. So that's easy to do ahead of time. Assess their pain levels. Make sure that one group isn't having more pain than another to begin with, or a different kind of pain, or a different source of pain. Okay, so they're counterbalanced. They're double-blind. They're randomly assigned to the two conditions, and it's a between, what we call a between groups design, in that it's two. We're pretending that we did this with two different groups. Okay, I've identified two matched groups of chronic pain sufferers with 12 participants in each group, 24 different people. Okay, split into two groups of 12. Another way that this could potentially be done is with half the number of participants, to just have 12 participants and measure them both before and after a period of meditation, and compare how they are before versus after meditation. That's called a within groups design. And we would get 24 data points from 12 people instead of requiring 24 people to get 24 data points. Do you see? Now, again, you'll talk about the pros and cons, the advantages and disadvantages of these two types of designs elsewhere, particularly in a methods course. So I don't want to go into too much detail about that now. But since I brought it up, the reason why I'm pretending I did a between subject design here is that there could be order effects with a within subject design. If I'm going to do it, you have the same people experience both conditions, perhaps pain gets better over, well, not perhaps, but generally we know that pain tends to get better over time. If it doesn't get better, people tend to cope with it differently and perhaps better. Conversely, some people get more sensitized to the pain and it becomes even harder to cope with and deal with. So the passage of time, if that's going to be, and that would have to be involved with a within subject design where people are doing both conditions, that could be problematic. So perhaps this is the best way to sort of just eliminate that possibility. So I can do it all at one time, not have to worry about the passage of time having some kind of effect either to reduce or decrease pain. Okay, so I'm going to have an experimental group that engages in meditation for the operationally defined type and period of time, and a control group that is not going to meditate and certainly doesn't know that they're not meditating in a covert sort of way. And the dependent measure, the dependent variable to measure pain, I'm going to imagine is just a simple self-report. Maybe not the best, but that's how I'm operationally defining it. On a scale of 1 to 10, how much pain are you in? 0 is pain-free. 10 is the screaming heebie-jeebie kind of pain that you can't imagine it being worse. Okay, so on a scale of 1 to 10, or 0 to 10, how much pain are you in sometime after the meditation? And again, we'll have clearly defined whether it's 1 day of meditation or 100. Okay, that's all. We'll imagine that's all taken care of. All right, well, here we go. So let's flash to the end, and there we are. There's our data, organized by the two groups. So I have a control group, again, that did not meditate, and there's their self-report pain scores, and here's the meditation group and their 12 individual pain scores. So take a look at that. There's only 24 numbers up on the screen. What do you think? What's your conclusion? Does meditation seem to help? Do those numbers in the meditation pile seem to be smaller, lower numbers, meaning less pain than the other group, or do they seem to be higher? Now, as you do that, ignore they're not paired, okay? So, this first person with the 7 in the control group has nothing to do with the person in this group with the pain level of 4. These are not the same persons. This one has nothing to do. It's just randomly. I could have put them in any random order here. So don't look across. That's not the proper way to compare this. All right. Well, looking at 24 numbers, 12 pairs of numbers, is a really tiny data set. This would be a ridiculously small study, but we're just using it as an example. And you can see that it's kind of challenging to look at even that small number of numbers and have a clear sense of what happened here. Okay? So, what's a better strategy to help you make that decision? Well, this course we're going to be covering what are called, as I mentioned earlier, descriptive statistics, and then we're going to move on to cover inferential statistics. So this is a good time to take a look at some of the descriptive stuff. So one of the first things that I like to do to describe the results, describe the data that we're looking at, is to paint a nice pretty picture. So to do that, I've entered it into SPSS, the statistical program we're going to be using this semester. Now, today, right now in this episode, I'm going to flash forward, or we're going to just flash through, and I'll show you the sort of end products of having done this in SPSS. In part 3 of this preview, I'm going to walk you through doing it. So I'll walk you through in a hopefully painless way. We'll open up SPSS, we'll put our data in, and we'll do all this stuff that I'm going to show you real quickly right now. So you can just sit back and enjoy it now, and in the next episode I'll walk you through doing it yourself, and you'll finally get some hands-on experience doing that. Okay, so here it is. I've entered it in SPSS, and I'll tell you more about that process in that next episode. So now I don't have two columns. You've probably already figured out how I've arranged this here. So I've got one column telling me which group the person is in, control group, the first 12 people, and the next 12 people in this meditation group. And the next column is their pain score. So we took those two columns and we kind of reorganized it. This is the proper way to do it in SPSS for this between subjects design that we've implemented. Okay? So that hasn't taken us anywhere towards seeing the results, but we're on our way. So let's take that data and make a graph. I like a graphical image of what I saw here, what I'm seeing here. All right, so I made a simple bar graph, and here's the control group, here's the meditation group, and on the y-axis we're looking at the mean pain. All right, I know pain is mean. That's not what I mean by mean. Mean means average, what you grew up calling the average. Okay, the average pain for the control group was, oh, I don't know, that looks like a little bit better than 5.5. Their average pain self-report was about 5.5 compared to about, what is that, maybe 4.25, 4.3 for the meditation group. All right, so it looks like there was a reduction. It looks like the meditation group has well, they do. A chipmunk can look at this. A squirrel can look at two piles of acorns and know that this pile is bigger than this pile. So congratulations, you're able to conduct an analysis just as quickly and swiftly as a squirrel could. All right, while we're looking at this, let me explain the TV antennas on top of these skyscrapers. These are called error bars. And as the legend says down here, it's showing plus and minus 1 SE. All right, these are one standard error bars, and today's not the day where we're going to learn about standard errors, but I'll just quickly mention what these bars tell us. There's something of a measure of how much variability was in this control group and how much variability was in this meditation group. Okay, obviously, as you saw in the raw data, not everybody gave the same score as their group members. There was variability. Some people had higher pain and lower pain scores. Okay, so the bars don't. The top of this bar does not mean that was the highest score reported in that group, and this is not the lowest score in that group. It's another fuzzier measure of that variability that we'll cover another time. Okay, so this is a good example of what's called an APA style graph. APA is the American Psychological Association, and they have a style that some of you might have learned how to use when in the writing class. Of course, when you write psychology papers from here on, you will write them in APA style, and we'll talk about APA style some other day. So this is a proper APA style, more or less proper APA style graph. In a true APA style graph, you would not have the title showing up here, but that's neither here nor there. Okay, so it looks like there was a reduction, but then again, maybe you didn't think so. That's the problem that we saw in the first episode. Who gets to decide if this is a big enough difference? Who gets to make that decision? All right, so we already talked about that there, and we talked about how we turn to a different kind of question. We don't ask the question, is that big enough? We ask that different Batman kind of question, what's the probability of seeing that amount of difference just by chance alone? Of course, we expect people to vary in their pain reports, okay? So we don't expect everybody to be equal, and therefore we don't expect the two group means to be precisely identical. So we do expect to see some difference. It would be odd, in fact, to see completely the same, all right? So we expect to see some difference, and the question then is, well, how different is weirdly different, okay? What is the chance? What's the probability of seeing this much difference just by chance. So remember, the two possibilities that we're going to chalk this up to, this difference, is one, it might be due to meditation. My God, maybe meditation works. Maybe it does reduce pain. All right, that's one possibility all by itself, the one that we tried to isolate here with our careful design. The other is every other possibility, all right, all the chance factors that collectively made up this possibility that we call chance. This could be due to chance, good luck, good design, bad design, just the regular amount of variability that we expect to see and all the other crappiness, all right? So it's either due to that or it's due to the treatment working, all right? That was the Batman-esque kind of question. Well, how do we answer that question? We answered that for this particular experiment with a particular inferential test. So the means and the graph itself are kind of, they're descriptive methods and descriptive components. Now let's turn to a preview of the inferential statistics, the way to infer if the result from this sample can tell us something about the larger population of pain sufferers. Okay, so the proper way to do that is with what's called an independent samples t-test. That's what SPSS calls it. So down here, it's reported an independent samples t-test. All right, you remember t-test, the guy from Guinness, the brewmaster from Guinness, who went under the pseudonym Student. He's the guy that gave us the T distribution and the T-test to help him answer these kinds of questions when he had 2 batches of beer that he was testing. Oh, is this beer, is it better with this kind of hops, or if I let them stew for this many days, or I don't know what variables he monkeyed with, but this is the kind of question that he realized he needed a tool to answer, so he created one, the T-test. Okay. Now, before I report on the t-test, let's take a look at this top table. Now, when I first put this screen up, some of you might have panicked a little bit. It's like, oh my God, look at all the numbers. Oh my God, numbers, numbers. Well, rest assured, by the end of the semester, by this point in about 10 weeks, you'll know all this. None of this will be a mystery to you. In fact, hopefully right now I can demystify it. There's nothing more empowering, nothing more superhero status kind of producing feeling than looking at an SPSS printout and not being scared of it. It's like looking down the Joker and saying you're not very scary. Okay, so the first table that SPSS produced are just some simple descriptives. All right, so there's the 2 groups, control and meditation. The N means the number. There were 12 people in each group. There's those 2 means that those bars were made from. All right, and so like I said, it looked like it was a little more than 5.5, 5.58, and I guessed correctly. It looked like it was about a 4.25 for the meditation group. There's the standard deviations, and that's another descriptive statistic we're about to cover, and it's a measure of the variability within the group. And I already mentioned the standard error. These are the standard errors of the means. Those 2 are very related. They're 2 measures of how much variability is in the 2 groups. Okay? This is an advanced topic. We won't talk right now about this so-called Levine's test for equality of variance, okay? So a little bit more advanced topic, so that's not what we came here to ask for. SPSS often gives you things you did not specifically ask for. And again, learning and knowing what they are is empowering, and so you don't have to look at SPS printouts and go, oh, I don't know what any of this means, especially this Levine's thing. All right, we came here for a t-test, and here's a column with t in it, okay? So there's the t. It took this data, and it transformed it with a magical process, the independent samples t-test, to produce a t. All right, now TL by itself right now means absolutely nothing to you, but let me tell you that right now, if you get a t close to, if you get a t close to 0, that basically means that this difference that we're looking at is very likely due to chance. If there's nothing going on, you'll get t's close to 0. When you get bigger t's, that starts to mean that, hey, maybe something's going on here. Maybe it's not so probable that this is due to chance. So, an advanced topic that we'll get to in several weeks, all right? So, there's my t, 3 point something, all right? Let's jump over a table. So, for now, right now. This is what we came in here for. If you remember nothing else from this entire semester, in fact, about SPSS and reading all this gobbledygook, this is what I want you to remember and know how to do. To read these SIG boxes, all right? SIG is short for significance. This thing is conducted what's called a two-tailed significance test, all right? There's one-tailed and two-tailed, and that's another topic we'll cover soon enough, all right? Significance test is another name for what we're doing here. We're testing what's called the significance. Now, significance does not mean importance, okay? A significant day in your life is, maybe the day you graduate or the day you get married or something like that, okay? Those are significant days. It's important days, okay? This is not an importance test. In statistics, we use this term in a very, non-standard kind of way, okay? I said that there's two possible reasons why we could be looking at a difference, and if it's due to the treatment, we say, oh, it's very unlikely that the chance is the reason. Okay, if we can reject chance as the explanation, we'll accept that alternative back in the utility belt that the treatment worked. Okay, and if we get there, we would say we have a significant difference. The difference that we see in the two bars is significant. It's beyond what we expect by chance. That's what significance means. It doesn't mean important. It doesn't mean it's big enough to be important. It doesn't mean it's big enough that everyone should drop their medications and start meditating. It would mean that this is beyond what we expect to see by chance. I expect to see some variability by chance, and pop, it's past a magic amount that means that it's significant, significantly different. Okay? Well, how do we interpret that? So there's a SIG box with a number in it. So you're always going to be asking the same question, at least at this level of the course. Okay? The question I want you to ask when you're looking at a SIG box is this. Is the number sitting there less than 0.05, 0.05? Is that number less than 0.05? Yes, it is. It's 0.006. All right, 0.05 refers to 5%. That's the proportion way to refer to 5%, 0.05, a proportion of 0.05. So the question again is, what's the chance that this could be due to chance? And it's telling us the chance that it's due to chance is so remote. It's 0.006. In other words, it's 0.6%. Do you see that? Anything less than 0.05 is less than 5%. This is less than 5%. It's less than 1%. It's 0.6%. There's only a 0.6% chance that that amount of difference that we saw was due to chance. That's kind of remarkable. So again, we started with that weird Batman-esque kind of question about the null hypothesis. My nothing hypothesis was that nothing happened here, nothing important. Pain is not affected by meditation. That wasn't my research hypothesis. That was my nothing, my null hypothesis. I didn't set out to try to demonstrate that one was correct. That's not interesting. Okay, but I start there, remember? I start there. And so my conclusion about chance as the explanation is that the likelihood is too remote. Less than 1% chance that that's the right answer. Well, let's break that null hypothesis, that ugly shiny glass knickknack. Okay, great, I get to drop it. The null is gone, that this is due to chance. Gone. And I get to reach back into the utility belt and pull my fish out. My alternative hypothesis that says, I think this is due to meditation. I think that this difference is due to meditation. I have not proven that it's due to meditation, right? We talked about that before. Scientists don't prove things. I have good evidence that suggests that meditation causes a decrease in pain in chronic sufferers, according to this result. This is made up data, so don't get too excited. But if it were real, I could go out on that limb and say, it looks like meditation serves to reduce pain. Okay, the rest will come to us. We'll learn what all of these numbers mean, and it won't be scary anymore. Okay, but now at least you know how to read the SIG box in an SPSS printout. And as you're going to see, much of our inferential tests resort to this exact same logic. And now you know. Now we're not finished. So there's still one more question that takes us back to the bad question that we rejected earlier in the other video. I talked about how we don't get to ask the question, is this different enough? Let me go back to the graph. So we've just discovered that this is a significant difference beyond what we'd expect to see just by chance alone, but it doesn't answer the more human kind of question, well, does it work? Should I use it? Should I stop taking medications and start taking meditation? If you are a pain sufferer, this might be a nice juicy result here. You know, if you're at this level of kind of screaming, laying in bed pain, if you could get down to this moaning but able to get out of bed level of pain, that might be well worth your time meditating, right? On the other hand, if this was a drug that was very expensive to take and had all kinds of horrible, nasty side effects, well, maybe this level of pain wouldn't be very interesting to you. So again, this isn't a great question to ask. Is this different enough for it to be significant and important on that level of the use of the word significance? Okay? But we still kind of like something about that question. So, and you can probably feel a little sense of lack of satisfaction in this rejecting the null hypothesis and kind of backhandedly accepting the alternative that treatment works. You can feel some dissatisfaction in that too, and you're not alone. So a new direction that we're taking in science, relatively new direction, is to kind of try to get back to that first question about asking is how big this effect is. And so we call that effect size, estimating the effect size. So we're saying there's an effect, and now we are going to try to quantify how big of an effect is it. We've just determined it's beyond what we'd expect to see by chance alone. Now we're going to try to answer the question, how big does the effect seem to be? That's not the same as asking, is it important? It's not. We're not going to be able to answer, should I reject other medications that I'm taking or other methods to reduce pain? It's never going to answer that, but at least I'll get an answer to well, how big is the effect that we're looking at? Okay? So, we're going to do it for this example with this relatively simple formula here. So we take the t that was on that previous output and plug it in and square it, and we do it again on the denominator down here, and we add something called the degree of freedom, which we'll look at another day, and take the square root of this and compute something called r. All right. So trust me on this, I plugged in the numbers, and r for this example is equal to sorry, that got split up here, awkward. R equals 0.55, not 55. That's a 0.55. Note to self, change this. So r equals 0.55, all right? And we consult another little table that tells me in words what does a 0.55 mean. And it says that it's a strong effect. Our options are really quite simple. If the number is below a certain number, we'll say it's small. When it gets to reach some middle level, we'll say it's medium. And when it reaches some other critical number, we'll say it's strong. Our range is from 0 to 1, so suffice it for now, 0.55 is equated with a strong effect. It's kind of like ordering a steak. It can be rare, medium, or well done. And hey, if you're right in between, if you like your steak somewhere between rare and medium, you say medium rare, all right? If it's somewhere between small and medium, you could say a small to medium size effect, and so on, okay? So it's not terribly precise sounding, just like you're unlikely to go into a restaurant and tell them what degree of temperature you want your steak cooked to. You say, I want it medium. You don't say, I want it 180 degrees or whatever. Okay? So, this is our kind of loosey-goosey way to talk about the effect size. So there we are. It's kind of a 1-2 punch, back to superhero terms. We test the significance, and today we have pow, a significant difference. And then we run an effect size calculation, and bang, we have a strong effect, a strong significant effect. Well, now it's time to tell the world what we found here, and so we might do it with a horrible looking sentence like this. This might be the sentence from a results section APA style write-up, APA style report of our results. So Upon completion of the meditation period, the chronic pain self-report scale was administered to participants in both the control and meditation groups. The participants in the meditation group reported lower pain scores, and I'm reporting the means and standard errors in parentheses there for the meditation group. And next, reporting the control group's mean and standard error. Okay? I go on. A two-tailed independent samples t-test was conducted and confirmed that this difference was significant. I had a t with 22 degrees of freedom, a term you'll learn and understand later. The t with 22 degrees of freedom was equal to 3.05. If you remember, that was roughly the number that was the t-test after rounding it. Okay, and the probability of that was less than 0.06. I could have also put right here p equals 0.006. That was the value I knew. I could have put in p equals 0.006. I opted for this other way. Sometimes we do it this way and we say it was less than 0.01, less than 1%. There was a less than 1% chance, okay? And we had an effect size estimate of r equals 0.55, considered to be strong. So there you go. You've learned how to get your descriptives, how to interpret your descriptive statistics and do the proper inferential test and read the printout of that, and how to explain the results to the rest of the community. So there's part 2 of your sneak preview to where we're going. Stay tuned for the next episode. We'll walk you through it. You'll try it out yourself using that multi-$1,000 program at your fingertips called SPSS. If you haven't already, make sure to go and get yourself hooked up with the cloud. I had another presentation demonstrating how you can get your computer that you're using set up to use the cloud, and therefore access that free version of SPSS. All right. So I hope that worked out for you, and I hope that will be a great way for you to use SPSS. And you don't have to schlep your body to the lab at HBU and do it on campus there. And you certainly won't have to buy the program. Okay? So if you don't have a computer to put that on yourself, beg and cajole somebody to let them put that program on their computer so that you can use it. Okay? See that video if you haven't already. If you have trouble with that, check with the help desk. Check with the help desk. They should be able to help you with any of those kinds of issues if you can't get something loaded up on your own computer from HPU that you're supposed to be able to. Okay, so hit me up if you have any questions about this. Otherwise, I'll look for you in part 3. Mahalo.